Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrunner, and in this video, I'm going to go through an example to analyze an AC circuit using mesh analysis. Okay, let's consider another example. Here's a circuit with two loops. This time we're going to use KVL. Suppose I give you the input is going to be 15 cosine of 1500 t volts. So wall power in the United States is 60 hertz, which is 377 radians per second, about. And this time I'm just going to use a different frequency, just to show you that you can use different frequencies, but it will not change. Okay, so here's our situation. Vn is 15 cosine of 1500 t volts, and so the frequency is 1500 radians per second. And we can then write this input in phasor notation as the magnitude 15 at an angle of 0 degrees because we don't have a phase angle. And of course the unit on that is volts. From there we can write the two loop equations. So going around the first loop, we end up with minus Vn plus R1 times I1, where I1 is the loop current, plus I1 minus I2 times 1 over j omega c. Okay, so just remember, of course, that ZC is equal to 1 over j omega c. So again, going through around that loop, minus Vn plus R1 times the loop current plus I1 minus I2, the difference in the loop currents, times 1 over j omega c is equal to 0. For the second loop, we have 1 over j omega c times I2 minus I1 plus j omega L I2 plus R2 I2 is equal to 0. Rewriting the equations and putting them in a matrix notation gives us, and I will just remind you how this works, 100 plus 1 over j times 0.0015 times I1 minus 1 over j times 0.0015 times I2 is equal to 15. Okay, remember we always this is just nothing more than matrix multiplication. This term times this term plus this term times this term is equal to this value. Then for the second equation, minus 1 over j times 0.0015 times I1, and then 1 over j times 0.0015 plus j 750 plus 75 times I2 is equal to 0. Solving, again, you can just do this directly with your calculator. Not all calculators will actually solve matrices with complex values. So if your calculator does not do that, you will need to know how to solve your equations using complex numbers. It's just like you would solve any equation with real numbers. It's just a little bit extra to keep track of. And you need to make sure you know how to do that with your calculator, or you can do it with MATLAB. And that gives you I will be equal to 0.0033 at an angle of 52.7063 degrees amps. And I2 is equal to 0.0196 at an angle of minus 85.3064 amps. So just to go through the MATLAB with you to show you what's going on, we type in, it's actually very simple, you type in the matrix A, and I have the echo on. If I wanted to suppress the echo, of course, I would put a semicolon after it. So then we see it. Notice there is a front multiplication by a constant. That just makes it maybe a little bit more difficult to read or easier to read, depending on your point of view. So we enter in A as a matrix. We enter in B as a matrix. I mean, it's a matrix. It's a vector. So we have two rows with one column. So we have 15 semicolon 0. That tells us it's going to be a column vector. Okay, and we can echo that. And then we do A backslash B. Okay, remember when we're solving with the matrix, we need to do A backslash B because we're solving for ax equal b, and so you have to multiply that A inverse. And so that's what this command does in MATLAB. That gives us our answer. Of course, our answer is in rectangular form. So I could have said I is equal to A backslash B, but instead I wrote A backslash B, and that gave me answer. So I then just say I is equal to answer. And then to get the magnitude, I just say ABS, absolute value of I, and this will be I1 and I2. And then I do angle of I and convert it to degrees, and that gives me the two different angles. And that was what we used to get our result right there.